The ground rumbles for days before anyone realizes the island itself is about to disappear. In 1883, the Krakatoa eruption was heard nearly 3,000 miles away, one of the loudest sounds in recorded history. People in Australia reported hearing what sounded like distant cannon fire. Most people assumed the eruption itself was the deadliest part. It wasn't. Krakatoa's final explosion destroyed most of the island, but the true death toll came from what happened next. Dr. Ben van Wyk de Vries, a volcanologist who has studied explosive island eruptions, has spent years analysing exactly why Krakatoa became so catastrophic. His research revealed something most people never expect. The eruption itself killed relatively few people directly. The collapse of the volcano triggered a series of massive tsunamis that struck the coastlines of Java and Sumatra, which means the greatest danger wasn't fire or ash, it was displaced ocean water arriving with no warning at all. So how does a volcano actually cause a tsunami?
When a large portion of an island collapses into the sea, it displaces an enormous volume of water almost instantly. Some of Krakatoa's tsunami waves reportedly reached heights of over 100 feet by the time they struck nearby shorelines, which means the ocean itself became the eruption's deadliest weapon hours after the explosion that triggered it. Here's the part almost nobody expects. Historical accounts suggest the death toll from Krakatoa's tsunamis vastly outnumbered deaths from the eruption's direct effects. Entire coastal villages were destroyed by waves that struck with almost no time to react, which means for people living near the coast that day, survival had almost nothing to do with the volcano they could see and everything to do with the wave they couldn't. Think about what happened to the sky itself. The eruption sent an enormous volume of ash and sulfur dioxide into the upper atmosphere. Sunsets around the world appeared unusually vivid for months afterward, a direct result of ash particles scattering light differently in the atmosphere. Which means Krakatoa's effects reached far beyond the immediate disaster zone, altering skies on the opposite side of the planet. Here's where the story gets stranger. Global temperatures reportedly dropped slightly in the year following the eruption. Scientists attribute this to sulfur aerosols reflecting sunlight back into space before it ever reached the ground. Which means a single volcanic event was powerful enough to measurably influence the entire planet's climate, at least temporarily. So what would survival actually look like for someone near a similar eruption today? Modern volcanic monitoring systems track seismic activity and gas emissions for warning signs long before a major eruption. Coastal tsunami warning systems, largely developed in the decades after Krakatoa, now provide critical minutes of advance notice in many regions. Which means today's survival odds depend heavily on infrastructure that simply didn't exist in 1883. Here's the part researchers find particularly telling. Krakatoa's volcanic system remains active today, having rebuilt itself into a new island known as Anak Krakatau. This new volcanic cone has erupted repeatedly since its formation, including a significant collapse and tsunami event as recently as 2018.
Which means the same geological forces that caused history's most infamous eruption are still active in the same location generations later. So could you actually survive a Krakatoa-level volcanic eruption nearby? The odds today would depend heavily on monitoring systems, tsunami warnings, and understanding that the wave, not the fire, is often the true danger. A distant rumble, a sky turning strange colours, a coastline that looks calm right up until it isn't. That sequence isn't chaos without pattern, It's geology and oceanography acting in a predictable, if brutal, order. Volcanic islands have collapsed into the sea for as long as volcanoes and oceans have coexisted, long before anyone built a warning system to read the signs. And maybe that's the real reframe. We think of volcanoes as producing their damage upward, in fire and ash reaching toward the sky. But some of history's deadliest eruptions did their worst work sideways, in the water rushing outward long after the smoke had cleared. The real lesson from Krakatoa was never just about the eruption. It's that the most dangerous part of a disaster can survive long after the disaster itself appears to be over.